I'm going fastest. So Unit 9 was ecology, all about this in your ecology book. So hopefully you did do your ecology book, otherwise you will struggle in this unit. So Unit 9 started on this side. Go over here. With your levels of ecological organization. This one is probably a repeat from middle school. The fact that you start with one individual, work your way up, increasing the amount of stuff you add as you go up. Member, one individual population is just a member of the same species. Community is several species. Ecosystem is when we add abiotic factors in. And biosphere is just several ecosystems. We're kind of just increasing each level. Your next part of your book went into energy flow and how energy moves in food webs and food chains. Remember, food webs are just food chains intermingled all together. You do need to know your terms for energy flow, what a heterotroph is, what an autotroph is, consumers, producers, apex predator, all stuff like that. Typically, we'll start from one level. Oh, and then your decomposers, your digivores. Autotroph means self. This auto means self. Trophic is energy, so that means self-energy. Hetero means they have to eat their energy. The energy always starts from the sun, and I wind up with what percentage? 100. I start with 100% of energy when I do photosynthesis. Things that eat me only get 10% of my energy. Things that eat the herbivores only wind up with 1% of the energy. And then my top guy gets 0.1% of energy. What am I losing energy as? Yeah. %90 of my energy gets lost as heat. Get my little photosynthesis. And then I always wind up going back into the soil with the decomposers. They wind up with the rest of the energy. Food chains work the exact same way. You probably will be asked on your SWL to identify sources of the food chain. Who is in the middle? Who is the person that is most sustainable for the environment? Stuff like that. Okay. We'll go to the right. We'll keep going, right? New topic here is the topic of succession. If you've never heard of it before, if you didn't do your green book, this is the one you want to at least make sure you looked over. So this first part is about primary succession. Primary succession is just how our ecosystems change over time, how your environment changes. It always starts being barren and works its way up to what we call a climax community. It's their best community. All right, I want to make sure you see it. Works your way up to a climax community. Basically, you're starting with nothing. Over time, you add a little bit of rocks. The rocks eventually break down into our soil, which is what we get here. Then we start getting a little bit of plants, a little bit of bigger plants, a little bit of bushes, a little bit of trees, working our way up to evergreens and coniferous trees and our climax community. That's secondary. So this would be new land masses. So this is new. So secondary succession is whenever that they were at a climax community and something happened to destroy it. So typically it's a natural disaster. It can also be like deforestation. Something broke it, deforestation. And then after time, the environment's going to try to rectify the way it lived. It's going to try to reclaim it. You'll see this like in old abandoned buildings where it looks like the forest is trying to reclaim them. There gets a bunch of vines and moss and stuff start popping up on it. The environment trying to reclaim it. So it's going to start back with the lichen and the moss, working its way up back to that climax community. It just didn't have to start from the rocks again. It did have that base layer there. So it kind of starts like right back at this point. And that's succession. So that's our reclaim. And then we'll go to your cycles. Okay? Okay. Cycles. Cycles of matter, you hear them called biogeochemical cycles. Basically, it's just your water cycle, carbon cycle, and nitrogen cycle. You have hopefully been doing your water cycle since elementary school, so that one you should know. I'm not going to go over your water cycle. The only one that might be new in here is going to be the thing of transpiration. Do you know what transpiration is? No. Transpiration is evaporation from plants. Think of that as your morning dew. That's just the presence of transpiration. You don't see it in your picture, but it would be if I had a little tree. That's where it would come from. Sometimes they'll put those on grass. It's literally evaporation from plants. Evaporation technically only happens from bodies of water, but plants do release water and it gets converted into gas. Carbon cycle, for the most part, is just going to be photosynthesis and cellular respiration. Throwing in a little bit of combustion in there, it's how we put carbon dioxide back into the atmosphere. So you'll see it has photosynthesis, respiration, and then a little bit of decomposition and a little bit of combustion. It's just putting CO2, all those words you should know. Then the last one, nitrogen cycle, is probably the newest cycle to you. The only big things they're going to ask you about the nitrogen cycle is this process of taking it from the environment. So we call that nitrogen fixation, where they take it from the sky. So they're taking atmospheric nitrogen and they're converting it into usable forms. That happens by bacteria in the soil. Bacteria convert it from ammonium to nitrate, which is more of a usable one, adding oxygen into it. That process is called nitrification. That's another one that might pop up. That's where you make it usable. You can use nitrates in your body. You can't use ammonium. So nitrification is when we make it usable for humans. After we use it, we don't need it anymore. We've used it already. It's decomposed. It gets sent back. We're going to wind up denitrifying it at the end, which is this process right here. Denitrification, which is when I pump it back up to the sky. Pump it back up. Those are the ones you might know about that they might mention, they might not. Good? Okay. Next one, vocab to know, right there in the middle. What does abiotic mean? Not living. What does biotic mean? Living. What is a climax community? Perfect. This is our goal. This is going to have a high level of biodiversity. And they're different based on what you do. We always talk about a forest in Virginia, so reaching that forest. Deserts can technically be climax communities. What's a niche? The first? Not the first. What's a niche? It's your role. I might see that one pop up. Typically, a lot of people confuse it with an area. A niche is kind of your role. Maybe you are the predator. You fill that niche. Maybe you are there to add stuff to the soil. What is symbiosis? A relationship. These are relationships. Typically, they live together. So that's mutualism, parasitism, commensalism. And then lastly, carrying capacity. What's a carrying capacity? How much you can support, right? The level the ecosystem can support. So whether that's due to resources or population size, demographics, etc., it is the maximum population the ecosystem supports. Which ties right into your last topic about population growth. Population growth typically deals with how populations change over time. So exponential growth, what is exponential growth? Rapid growth, right? What's linear growth? It's more of a straight line. So that's when I'm growing more of a stable growth. Going more of a stable one. This one that we see most of the time is a log growth, logistic growth. We want our populations to grow logistically, eventually reaching a point that they stop. What is a limiting factor? What is something limiting in terms of population? And what would limit my size? So in Norfolk, in Norfolk, we can't get more. Okay, in the school building, we can't get more kids. Why? Space. Space. Something that's going to prevent population growth. Unlimited. Space, resources, disease. Okay. Density dependent. What is density? What is density? How close things are, how far apart, how many people exist in an area, right? So if something's density dependent, what would that be? What would affect me density dependently in terms of population? Disease. disease, food, health, right? More people I have, quicker that disease is going to knock us out. What would be density independent? Natural disasters. Even just temperature. Water. Doesn't matter how many people I got. If it's hot, we're gonna die. No matter how many people I got, if we don't got water, we're gonna die. And that was the end for Unit 9.